This video will cover page 1 of the notes for Tuesday. If you have access to a printer and are able, I recommend that you print the template out ahead of time, as it's going to save you work while all you need to do is fill in the blanks and do the problems. Otherwise, do this in your notebooks. Alright, here we go. Recall from last week, we looked at the form y equals mx plus b, which is called slope-intercept form. In the slope-intercept form, you know the slope and the y-intercept. If you know the slope and the y-intercept of function, you can write it in the form y equals mx plus b, where m is the slope and the y-intercept is the coordinate 0, b. Always a coordinate. Now, you're not always going to know the y-intercept, or other times the y-intercept may not be a nice easy integer, in which case you're going to want another form. This other form is called point-slope form. It's another way to write the equation for linear functions. Now, in point-slope form, it looks like this, and it can actually look one of two ways. Either y equals m times the quantity x minus x1 plus y1, or sometimes it's written as y minus y1 equals m quantity x minus x1. Now, Apex will use the second form, where in a typical year we use the first form. So we need you to know both forms so that you're capable of passing through Apex, but also being prepared for next year. Now, in this form, m is still the slope. x1 and y1 are going to be parts of a known point, some coordinate. So x1 is the x part of the known point, and y1 is the y part of the known point. Now, in the other form of point slope over here on the right-hand side, m is still the slope. It still has x1, which is the x part of the known point, and it still has y1, it's just moved. Now we're going to look at the difference between these two forms. Here they are again. And what do you notice is different between the form on the left and the form on the right? Hopefully you just notice that the y1 has been subtracted to the other side. Instead of y equals m quantity x minus x1 plus y1, if we subtract y1 to move it to the left-hand side, we get the other form. So it's nothing more than just the second form has y1 subtracted to the left-hand side of the equation. Now again, Apex will tend to use the notation on the right-hand side, where typically we use the notation on the left-hand side because it's more useful. That we can take the same general form, we really call this almost like a transformational form, and we can use it later on when we get to quadratics, exponentials, and basically any other type of function. Okay, so this form really is very handy. All right, well, let's see how to use it. Here, in the examples, I have a set of information. I'm told that the slope of a line is 2/3, and it passes through the point 2, -8. And I want to write it in point-slope form. Now we're going to ask that you write both methods of point-slope. We're going to start with the form on the left, and then we'll also write it as the other form on the right. All right, let's do this. Again, the way I do it is I normally start by writing out the equation, y equals m quantity, x minus x1 plus y1, and then substitute in what I know. Here, the slope is 2/3, so we'll replace m with 2/3. The x part of the known point is 2, and the y part of the known point is -8. So substituting this in, we get y equals 2/3 times the quantity x minus, substitute in our 2, close the parentheses, and then we plug in y1 plus -8 just becomes -8. Now to get the other form, we're going to move the 8 to the other side. Now it's already subtracted, which means if we add it to the other side, we'd get y plus 8 equals the 2/3 quantity x minus 2, and this is the other form. You write it like the first form, and then you simply move the constant to the other side. Well, let's try with another example. This time the slope is -5, and the known point is -3,7. I start by writing the general form, and then I substitute it in. Y equals, instead of m we can substitute -5, x minus, but the x part is already a -3. We're going to get x minus a -3, and then plus 7. Now we don't want to leave it in this form where you have in the parentheses the double negative. So the x minus a -3, the double negative is really just x plus 3. So we get y equals -5 times the quantity x plus 3 plus 7. Now to get to the other form, we'll move the constant to the other side. So this means we'll subtract 7 from each side and get y minus 7 equals -5 quantity x plus 3. It's pretty straightforward. Now keep in mind, look, notice in the parentheses we have x plus. It's supposed to be an x minus. So if you see something that says x plus in the parentheses, you know the x part of the coordinate is therefore negative, because the negative makes a positive. Okay, that's just a little tip off. When you see x plus in the parentheses, we know we have a negative x part. All right, so now we're going to go the other way. Here's three equations that are written in point-slope form, and we want to find the slope and the point. Now, if it's something like in number 3, where the y1 is on the left-hand side, we're going to start by moving that back. So on number 3 here, we're going to start by adding 2 to the other side, both sides. If we add 2 to both sides, that'll push the 2 to the other side, to the right-hand side, and we got y equals, the negative 2's cancel out on the left, negative 3 times the quantity, x plus 4, and then now plus 2. We can see pretty clearly that the slope, the number in front of the parentheses, is the negative 3. In the parentheses, it should be x minus, and it's not. So like I said before, if you see the x plus 4, that's telling you it's really x minus the negative 4. So the x part of that known point is negative 4. And then the y is just whatever it says over here when it's in this form. In this case, y is 2. So if x1 is 4 and y1 is 2, say negative 4 and 2, then the coordinate is negative 4, 2. Now number 4 here, this next example, this is already in the form we like. So I'm going to let you try to work this problem out. If you need to, pause the video and work out numbers 4 and 5. When you're ready to check your answers, resume the video. I'll give you a moment. All right, hopefully you had a chance to work these ones out. It's already in the form where the y1 is on the right-hand side, so we can look at it and figure out what we see here. In this case, the slope is 5, and in the parentheses we have x minus, which means x1 is 2, and the y1 is negative 9. So the coordinate would be 2 comma negative 9. Now problem 5 here is not in the form I want to see. I want to move the 7. So if we move the 7 to the other side by subtracting from both sides, we would get y equals 3 times the quantity x plus 2 minus 7. We can see the slope, in this case, is 3. It should be x minus, and it's not, which means this is really x minus a negative 2. The x portion of the coordinate is negative 2, and the y part is negative 7. So the coordinate would be negative 2, negative 7. Now let's try it with some graphs. We're going to look at these graphs, we're going to find the slope and one of the known points, and we're going to write the equation in point-slope form. Now you'll notice that the reason I'm not using slope-intercept form is because they don't have nice integer y-intercepts. I would have to estimate, and that's not accurate. I don't know, for instance, on number 6, whether it's something in between 3 and 4, but what is it? So instead, we'll use point-slope form because I can clearly see where those points are. All right, we're going to first find the slope. So on number 6, I see it's got a negative slope because it goes down as you go to the right. In particular, it's going down 1 as you go 2 to the right. So the slope here is negative 1/2. And then we pick some known point. For instance, let's take the point 1, 3. If we substitute this information, the slope and the point, into the form y equals m quantity x minus x1 plus y1, or point-slope form, we can find the equation. So instead of m, we'll substitute negative 1/2, and we get y equals negative 1/2 times the quantity x minus 1, close it, and then plus 3. And there's one of our forms. Now to get the other form, we'll simply move the constant to the other side. Subtracting 3 from both sides, we get y minus 3 equals negative 1/2 quantity x minus 1. But we could also use the other coordinate. Instead of 1, 3, it'd also be possible to use 3, 2. If we use 3, 2, we would get this. Y equals negative 1/2 still, times the quantity, but now it'd be x minus 3 because now the x part of the known coordinate is 3. And the y part is positive 2. Or if we move the 2 to the other side, y minus 2 equals negative 1/2 quantity x minus 3. Now the equations in yellow and blue here may look like they're different equations, and you may be asking yourself, how's that possible? How can I get different equations for the same line? Well, in reality, they're not different. They're equivalent, they just look a little different. If we were to distribute the negative 1/2 into the parentheses, and then combine like terms, we would actually get the same equations for both of these. So they may look a little different, but they would still give us the same form if we were to fully simplify them. Well, let's look at number 7 here. On 7, I can see it's a positive slope, and I can go up and over to see that the slope is going to be up 5 and 4 to the right. The slope here is positive 5/4. Picking one of the points, for instance 3, 2 on the right, I can write the equation. Substituting in what I see, the slope, or m, is going to be 5/4. The x portion of the coordinate is 3, and the y portion is 2. This will give me y equals 5/4 times the quantity x minus 3 plus 2. Or if we rewrite it by subtracting 2 from both sides, y minus 2 equals 5/4 times the quantity x minus 3. But here again, we could use other coordinate on the line. We could also use the one on the left-hand side, which is -1, -3. In which case, the slope is still 5/4, but in the parentheses, we'd have x minus a -1, which would become x plus 1, and then the minus 3. Or, adding 3 to both sides, y plus 3 equals 5/4 times the quantity x plus 1. Now again, the yellow and the blue equations may look different, but they're equivalent. They have the same value because they have the same slope, and if you were to distribute and combine like terms, you would get identical equations. All right, last one here. Actually, why don't you try this one? Why don't you pause the video, work this one out, and see what you get, and then resume the video when you're ready to check your answers. I'll give you a moment again. All right, hopefully you worked it out. We can see that it has a positive slope, and in particular, it's going up 2 when you go over 6. 2 6 this time is actually going to reduce, and this becomes a positive 1/3. Now I'm going to use the coordinate -4, 2 and see what I get. Substituting the form y equals m times the quantity x minus x1 plus y1, point slope form, we would get y equals, the slope is 1/3, times the quantity x minus a -4 becomes x plus 4, and then plus 2. Or, moving 2 to the other side, y minus 2 equals 1/3 times the quantity x plus 4. Now again, I do have another coordinate I could use. I could use the one on the right-hand side, which is at 2, 4. Substituting it in, I get y equals 1/3 times the quantity x minus our x part, which is 2, and then plus 4, which is the y part. Or, subtracting 4 from both sides, y minus 4 equals 1/3 times the quantity x minus 2. Now it doesn't matter which point you use. It doesn't matter whether you use the -4, 2 or the 2, 4, because they're both going to give you equivalent equations. Either one of these is correct. All right, well, thank you for watching this first part. Again, if you need to rewind the video to catch something that you missed, just do that. And then get ready to watch the next video, which will be the second page of the worksheet and the notes. Thank you for watching.